Hello and welcome to PCI Tech TV. In today's Tech TV episode, we will provide you an overview of PCI's new, fast, and accurate high-quality orthomosaic capability that uses an innovative 2.5D hybrid digital surface model editing technique that allows instant ortho preview on the fly. This new technology has recently been released in GXL 2013. The project we'll be working with includes imagery of Quebec City collected at 10 centimeter resolution. Let's start by opening the DSM so we can make edits and improve the end quality of our orthos. Here's the DSM of 18 images over Quebec City, and these 18 images have 60% forward overlap and 30% side overlap, which have been used by GXL to create the digital surface model. When I load the DSM, the default view is in grayscale. I'll go ahead and start the DSM Editing toolbar, which is going to automatically change our view to provide a color shaded relief view of the digital surface model. If I zoom out to the overview, you can see that the DSM is quite detailed. We have a number of different features, some smaller buildings, which are residential areas in different parts of the imagery here. We have this large feature here, which is a rock quarry that stretches for several kilometers. Some larger features, these are industrial buildings. And through the middle of the image, we have a highway. This is a major highway, the A40, that juts out into the St. Lawrence. This is actually the St. Lawrence Seaway. And some complex structures which you will need to fix in order to produce nice looking orthos. Our DSM editing panel has different options. We can switch between the DSM view, the color shaded relief DSM view, and the Ortho Preview. This Ortho Preview is a preliminary orthomosaic that's been created using the digital terrain model that's been calculated when we created the digital surface model. The digital terrain model is not ideal because it hasn't been localized to take into account some of the different elevation features that we can fix using the 2.5D editing techniques. Let's switch back to the DSM and we'll start by zooming in on a residential area. As you can see, the preliminary orthomosaic that's been created has some issues. The trees are smeared, the roof lines of the residential dwellings are not straight, and in general this just isn't an acceptable image for an end customer. And the reason for this is because the DSM hasn't really been corrected properly in our DSM to DTM conversion. However, using these 2.5D editing tools, which I'm about to demonstrate, we'll be able to remove the dwellings and flatten the elevation and produce a much nicer looking ortho. So the first thing I'll do is create a polygon layer, and this is going to allow me to enter polygons and apply different filters to remove the elevation. So I've got my polygon layer selected. I'll create a new polygon. So I'll just digitize around these dwellings here, leaving some room around them. This is very simple, just clicking through. And again, I'm working on a smaller area, but this type of approach could be applied to a much larger area. Now that I have my area selected, I can choose one of the different filters that's available. So I'll go ahead and choose Terrain Filter. I'll leave the size at 100. This is the search radius, and the gradient at 30%. And if I click Apply, you can see that we've removed the dwellings from the digital surface model and averaged out the elevation with the ground. Now I can take a look and see how this looks without having to regenerate the DTM and generate an ortho and go through all this complicated processing. I can simply click here on the 1:1, load this area at 1:1, and what this is going to do now is give me a view of the end mosaic and orthomosaic that I will have at the end of this process once I generate it. Now if I zoom in at 1:1 again on this imagery, you can see that the building outlines are straight. We've removed a lot of the distortions. The trees no longer appear smeared, and that's just because we've removed the elevation from the digital surface model to average out the values, and that produces a much nicer looking ortho mosaic product.